Here's pre-calc lesson 7, inductive and deductive reasoning. So we're going to just get some vocab down. What is inductive reasoning and what is deductive reasoning? I would like you to read all this, especially if you don't understand how I explain it. But basically, inductive reasoning is when you don't really have a rule, but you're just making an observation, and based on that observation you kind of formulate a rule. So you're inducing something based on observations that you have. Deductive reasoning is when you're using a rule that's already been formulated. Okay, so there's a difference. Inductive reasoning, you don't have a rule, but you are kind of making up a rule, and then deductive reasoning, there's already a rule and you're just using it. So there's your two vocab. You should probably read what the author says here. I have to go a little bit fast because this is a long lesson. I gotta fit it into my 10 YouTube minutes. Okay, so we're gonna study syllogisms. So in a syllogism, you have a major premise and a minor premise and a conclusion. And you might have seen these before. All men are mortal. Aristotle is a man, therefore Aristotle is mortal. Basically, the way these things work is the major premise will say something about some category, like the category of men. And then if the minor premise follows, or if the minor premise identifies a member of the major premise, then you can go ahead and take this last part to be your conclusion. So it's kind of like the second line is going to match with the very first part of the first line, and then this last part of the first line is going to be your conclusion. You should probably read all this here, but I'm going to kind of just show you how to do them because I don't have that much time. This one right here, this part's the major premise, then we got the minor premise, and then we have a conclusion. Let's see if it's valid. So the major premise says the sum of the exterior angles of a convex polygon is 360. So if I wanted to boil that down, I'd say if it's a convex polygon, then the angles add to 360, the exterior angles. So this is my category I'm looking for in line 2. Is this a member of the category of convex polygons? Yes, it is. So I can safely conclude that if it's a member of the complex polygons, then it's going to have the exterior angles are going to add to 360. Let's keep doing some. You're going to get it just by me doing a few of them. All frogs are green. So if this second line is talking about a frog, I can assume that it's green because it says all frogs are green. This is valid. And so your author of your book also talks about, well, maybe there's somebody in the class that's saying, you know what, I have a pet frog and he's brown, so this thing isn't even true. Well, we're not caring if the major or the minor premises are true. We're just the only thing we care about is if we're using the reasoning properly. Meaning whatever that top premise says, the second one has to match the category, or has to be a member of that category, whatever the category is. And then we have to draw a valid conclusion based on those premises. We're not questioning whether the premises are true or not. Okay, and you can read that in here in your book if you want to. Here's another one. If it rains, I will go to town. So the category that we're looking for is if it rained. And this down here says it did not rain. So it kind of matches, but not really, because it said it didn't rain. It's like kind of opposite, right? So this is not, so wait a second. If it rains, I will go to town. It did not rain, therefore, no, this has to match right here. These two don't match, so that's not going to work. Okay, and if you want to read what they say, about it. They say the conclusion in the following syllogism is invalid because the argument is faulty. As the minor premise, this one down here, does not identify a member of the set defined by the major premise. So see, these don't match, so that makes it not work. The major premise identified a result on each member of the set of days on which rain occurred. It made no statement about the set of days on which there was no rain. Thus, the day in question is not a member of the established set and may or may not possess the property in question. Here's another one. All normal dogs have 4 legs. Yeah, you can't see it. So I'm looking for this second one to say something about normal dogs, and it doesn't. It says that dog has 4 legs. So this second line, the minor premise, it's kind of matching with this over here. I need it to match with that, with the normal dogs. So that is not going to give me a valid argument. That argument is invalid. And it says right here, for a valid argument, the minor premise should have stated that a particular dog was a member of this set. The set of normal dogs, not the set of dogs that have 4 legs. What about this one? Is this a valid argument? All boys are good. No, because this should say boys. This should say that child is a boy, and then down here it could say therefore that child is good. See how it doesn't match? These two, those aren't what we want to go together. We want this second line to go with that first part. We want them to match. How about this one? All chickens have 3 legs. Henny Penny's a chicken. So chicken, look, chicken, chicken. These two go together. That's good. That means that this part down here is the conclusion. So that's a valid argument. Okay, so the contrapositive. I think, well, should I make up my... I have my own little way of saying this. Let's look in their little box. So these are premises. This is called a premise. If an animal is a rabbit, then the animal is a fast runner. So we can break this down, and instead of saying if then, we call this P. I know it's kind of weird. I'm not really sure why. Maybe for premise. And this is Q. Check your Latin. Maybe that has. I'm not sure why they use those 2 letters of the alphabet. So I can. Here, I'm going to go ahead and get my own. The if statement, I can say if something, then something. Well, that's called a premise. And we like to abbreviate it as P, then Q. Or if P, then Q. In some classes, they'll say P implies Q. Okay? The first part, the if part, or the P part, is called the hypothesis. So what did it say? If it's a rabbit, then it's a fast runner. So the if it's a rabbit part is a hypothesis, and then it's a fast runner part is a conclusion. Okay, so the first part's hypothesis, the second part's a conclusion, the whole thing is called a premise. Now there's a thing called a contrapositive. The contrapositive says, if not, the second part, oh, you know what? I think I have this thing. I have something written wrong here too. Let me fix it. Inverse. I messed up part of this. I wrote my little sign wrong. And this is the converse. That's going to make it really easy to understand, huh? Sorry about that. Okay, so if you have a contrapositive, like remember we were saying if it's a rabbit, then it's a fast runner. I could say if it's not a fast runner, then it's not a rabbit. That would have the same truth value as the premise. These other ones don't necessarily have the same truth value. So this one, if I use my rabbit example, this would say if it's not a rabbit, then it's not a fast runner. That's not necessarily true. And in this one, the converse would say, if it's a fast runner, then it's a rabbit. Remember, our original one was, if it's a rabbit, then it's a fast runner. So the converse just takes it and flips it. So sometimes converses are true and sometimes they're not. Same thing with inverses. But contrapositives are always true. The same. It says, you're wondering what it says, right? Same truth value as the premise. Okay. I'm running out of time on my YouTube video, so we'll talk more in class about this. But I want to show you the very bottom of the page. When the converse is true, you can say that you have this. P then Q. So this would be like, if you have a measure of 90 degrees, then it's a right angle. Well, this goes both ways, because I can say if it's a right angle, then it has 90 degrees. So there's a notation for it, and it looks like this. And we say if, I-F-F, or if and only if. Okay, so that's on the bottom of your lesson 7. Okay, so you learned contrapositive, inverse, converse. I got to end it.